Welcome to lecture 6, welding fundamentals and resistance welding. In the last lecture, we have finished the casting, the topic casting, and then today we're going to start with welding fundamentals and resistance welding. So to define welding, it's basically a joining method of two metals together, either using heat or without using heat. And to produce that heat, there might be different methods to produce heat. It can be electrical resistance, electric arc, uh, gas heating, or induction heating. So whatever the heating type is, the main purpose of welding is to join two metals together. Okay. Here's an example for arc welding, in which we need to have a power supply to produce electric arc. Just to give you the fundamental idea about arc welding or welding. In here we have a power supply that gives us the required energy to conduct the welding process, and that can be, the power supply can be either AC or DC. Both can be used. Both have also merits and demerits, which we'll discuss them later on when we study the arc welding method. Okay, and in here there is an electrode holder that actually holds an electrode. To understand the electrode is basically when you join two metals like this. Let's say this is one piece of metal and there is another piece of metal in here. And for proper welding of highly thick metal sheets, this can be treated as thick metal sheets. If you want to weld it, then you need to apply heat to you have to melt all of this full location, and then if you melt it, then there's a gap between the specimen. The metal actually flows into that gap, and also there is a gap due to the edge preparation. Before welding, you need to prepare the edges, and that gap also needs to be filled with extra metal. And the electrode actually provides that extra metal into that space. This is the one of the function of the electrode, and another function is to conduct the electricity. If there is an electrode and there is a certain gap between electrode and workpiece, because the workpiece is connected with the power supply in here, and also the electrode is connected with the power supply. Due to the gap between electrode and the workpiece, there will be air resistance present in this location, and because of that air resistance and low voltage and high current density, there will be a arc generated in this location. And due to the generation of arc, the temperature will increase like 3000 to 4000 degrees Celsius. And due to that high temperature, metal actually melts, base metal melts. That means these two metals can be treated as base metal, and this is the electrode. The base metal melts, at the same time electrode also melts, and that's why this location in here, this location actually becomes completely liquid. And then once you propagate the welding, that means you propagate the electrode in the different location, then this metal gets solidified, the liquid metal gets solidified, and then the proper joining occurs in this region. Okay, that's what happens in this region. Okay. Okay, any question here?
No, sir.
All right. So what are the advantages of welding over other joint? There can there can be many other joining methods, like you can use bolted joint, you can use like soldering, or also the brazing. Those can be other joining methods, but the major other for other joining methods, the major joining method that we can consider is the bolted joint. If we want to compare the welding joint with the bolted joint, then there are several advantages of welding over those other joints. First of all, it is like structures can be made very lighter and higher due to reduction of weight. For example, if we talk about the Eiffel Tower, it's a very high structure, right? And that high structure has a significant amount of weight. Instead of joining the links with using welding, if we would join those links, let's say this is an Eiffel Tower, okay, and these are the trash structures that's how we join the Eiffel Tower was made. And these joining locations, if we use bolted joint, there will be extra weight in each joints. But uh, but if you do the welding, then that extra weight will be reduced, and that's why the more higher structure uh, can be produced using welding joints. That's why it says that lighter and higher structures can be made. Second one is the joint have the corrosion resistance compared to bolted and riveted joints. For example, if you have a two metal pitches joined together with the help of a bolt in this region, how the corrosion actually works. Corrosion works in such a way that when the water particles are trapped into the small corners of the bolts of the bolt, then due to that entrapment of that water particle, that actually reacts with the metal and forms the metal oxide. And that metal oxide is very brittle and can be with very low strength, and that's why that those metal oxide can be uh, removed from that surface very easily, and that causes the corrosion. And when you join with the bolt, then there will be sharp corners around the bolt, and in those sharp corners the water particles can be easily entrapped and corrosion is propagated. But if you use the welded joint instead of this bolt, if you use the welded joint around these, then the sharp corners will be reduced. And due to the reduction of sharp corner or intermetallic gap, the corrosion can be significantly reduced. And the fluid type for tanks and vessels, if you want to produce the tanks or vessels that is without any leakage, then obviously welding is the better option compared to the not bolted joint. Because bolted, if you use the bolted joint, you can do that, but the problem is using the bolted joint, you need to have like gaskets or other sealing method to be applied in those locations. So which is not convenient. So the welding is better compared to the riveted or bolted joints. And the welded structure can be altered easily and economically. If you need to make certain design changes in your structure, then welding is much better compared to the riveted or bolted joint. For example, if you want to change change this design in some manner, then you can just cut it off and then put an extra plate in here and then do the welding. But if you want to modify the design with the nut bolted joint, then you have to do some extra works. That is, you have to remove all of these and then you put that one and do the drilling, and then you get maybe the one bolt is not enough, then you might have to have like 2-3 bolts together, and there's a huge large amount of extra works involved in this case. And that is why it say that the welding is more economical in terms of altering the design. In terms of altering the design, so the welding is better. And another thing is that many different joints are possible in welded joints, which is not possible in the case of bolted joint. For example, if you want to join two metal pieces like parallelly with each other in this location, okay, then the welding is very much it's very easy if you do the welding. But if you want to join these metal pieces together with the help of nut and bolts, then you have to have like extra plates placed in this location, and then you use the bolt nuts and bolts, okay, which is kind of huge amount of extra work. So these are the advantages of welding over other joints. Do you have any question in here?
Sir, how the structure become lighter due to welding system?
Okay, this was the example in here. If you look at this example, let's say you have two metal pieces, you need to join them together in this location. Okay, then you weld in this location, and then the metal are joined. The amount of
Yes,
extra metal required in this location will be very less compared to when you join it by riveted or bolted joint using an extra plate and using nuts and bolts. The weight will be higher, right?
oh, yes, yes, sir.
Yep.
I
Okay.
understand.
Okay. Any other question?
No, sir.
Okay. What are the conditions we need to fulfill before conducting a proper welding? If you want to do a welding properly, then you must consider these four parameters very carefully to get a better performance after the fabrication when the that part will be in service. The first of all is the surfaces should be clean and free from foreign materials. That means the surfaces that you are going to weld together must be clean. Otherwise, those extra foreign materials that are present on the surface will be mixed with the liquid metal that is formed due to the welding, and that will create problem, and the mechanical property will degrade. Okay, and that will also sometimes result the premature failure of the components. And second one is the proper edge preparation. Edge preparation is very important for welding, because if you want to join two thick piece of metals, let's say this is one of thick piece of metal and this is another thick piece of metal, and you want to, let's say this dimension is like 15 millimeter. If this is 15 millimeter height and you want to do the welding from here, this is the electrode, let's say this is the electrode. And what will happen is that if you want to do the proper welding, that means you want to cover all the whole joint here, then you have to have like proper electrode selection. That is one of the condition. And second one is that it is very difficult and it will be very time consuming to do the welding. Instead, if you prepare the edges properly, like this, you make the edges kind of sharp corners, kind of filleted edges, and then if you do the welding, then you just have to melt this portion, and then the rest of the portion will be filled with the electrode material. Okay, and that's why you need to prepare the edges properly. And also the gaps between the plates should be kept at an optimum value. That means the gap between the plates, this is the gap between the plates. If the gap is not proper, then heat or liquid metal cannot flow into these regions. Okay, and then welding time will increase. Okay, and that will not give you the proper joint up to the bottom of the specimens. And the fourthly, the oxidation. Oxidation is a very common phenomenon in welding, because whenever a metal is subjected to a very high temperature, then oxidation occurs. That means metal actually reacts with the oxygen and forms metal oxide. And due to the formation of metal oxide, the metal oxides are basically impurities. Those sometimes called slag. And those if the impurities are formed into the material structure, and then the failure actually occurs during the service. Failure actually initiates in those regions. Okay, and that is why you need to take care of the oxidation. How do you take care of the oxidation problem? We'll discuss about that in our later slides when we discuss various welding methods. Okay? The different welding method has different ways to mitigate the oxidation. Okay, any question?
Sir,
Okay.
in the previous slide, we see the advantages of welding, but there is any disadvantage of welding?
Yes, of course, there is disadvantages too. Okay. The disadvantages are not much actually, because sometimes it depends on the application. For example, if you want to use, for example, if you want to use two cylinders connected together, okay. For example, if you want to connect these two cylinder with the filleted joint, you can do it with the, let's say these are two cylinders, pipelines actually. Two pipelines can be joined together with the help of bolts. Okay, you can use the bolts in here, in here, in here. Okay, and also if you use the bolt system, then there is extra weight. Okay, but if you use the welding, then it will be joined together. There weight will be less. But the problem here is that if you need to disassemble this frequently, okay, if you want to disassemble this assembly frequently, then welding is not a good option for this. That will be the disadvantage of the welding. Okay, that means you cannot frequently change the structure. That means you cannot uh, if you talk about the welding, then it's a permanent joint. Okay, if you require permanent joint, then you can do the welding. But if you require a joint that will be frequently opened and closed, then in that case welding is not a good option. Okay,
Okay, sir.
what are the types of joints that can be done using welding? First of all is the butt joint, which is difficult in terms of other welding, other joining method. This is very easy for joining two metal pieces together parallelly, and then there is corner joint, lap joint on top of each other. Plates will be on top of each other, and then you do the joining in this location, and that is called lap joint. And there will be T joint and also is joint. Okay. And the terminology, once the welding is done, then the structure that is formed due to the butt weld, this is the butt weld joint, and the structure that is formed if you cut through the specimen, then the structure will look like this. Okay, the weld zone will be like this. Okay, and if you want to know actually the purpose of this slide is to know the terminology that are used in welding. Okay, first of all is the top surface. The top surface is called the face. Okay, let's just start with actually the before welding. Okay, before welding, this dot line, dash line that you are seeing, this was the situation before welding. Okay, this is the prepared edge. Okay, before welding, the metal two metal pieces will look like that. These dash lines, and the gap between the two workpiece is called the root opening, and this location is called the root. Okay, and root opening has a dimension like millimeter, like how many millimeter dimension you need to provide for the root opening, and root is the location. It does not have any unit. It is the location. That is the bottom of the specimen is called the root. Okay, and there can be some backing plates to facilitate that, so that the material does not go out of the throat. Okay. And the throat is the gap that has been introduced for joining the material. Okay, this is called the throat. And after joining, and the toe is also this location on top of left and right. These two locations are called the toes of welding. And after welding, when the welding is completed, then there will be some excess material on top of it. And from the base material surface to the excess material surface is called the reinforcement. Okay, most of the time actually this face, the reinforcement from the face is actually removed with the help of grinding to get a proper finished surface. And also same things happens at the bottom. Okay, the bottom extra material at the bottom, these extra materials are actually grinded off to get the proper finishing. Okay, and since this location is subjected to a very high temperature, that will affect the base metals too. That means some of the base metal will be melt. Okay, that means this location, if you look at this location, this is the initial location and then this is the final location after welding. So this material, this metal actually melted. Okay, this molten material then after reaching to the room temperature, this material gets solidified. And the close to that location after melting point. Okay, after this location, due to the high temperature, this material is molten, and due to the high temperature, there will be a certain region where the molten, due to the high temperature, the material characteristic will change. Okay, and that region is called the heat affected zone. This is the molten zone that is in the throat, and after that there will be a small area that this area is actually represents the heat affected zone. Due to the high temperature, base metal gets affected. As you know that a term is called the heat treatment. Okay, due to the high temperature, material property can be changed by heating the metals at different temperature, and because of that high temperature, this material actually gets treated due to the heat, and that zone is called the heat affected zone. We will discuss this heat affected zone in the later slide in more details. Okay, how the internal structure actually changes. Okay, any question in here? This is just the this slide is all about the terminology, which region or which space is called what. Okay.
Sorry, sir, I don't understand the whole process due to network problem.
If it is due to the network problem, then the recording will be available, so you can watch the video later. Okay.
Sir, can you explain the function of backing?
A function of backing plate, it's not essential to have the backing plate. Sometimes when larger structures are welded together, then to stop traveling the liquid metal below through the root to the bottom, okay, a backing plate can be used. Okay, and later on that backing plate is actually removed from there. Okay, any more question? All right, the terminology is slightly different in the case of fillet welds. In the case of fillet weld, the terminology it is basically the effective throat is basically changed compared with the butt joint. In this case, the effective throat will be the distance between this line and that line. Okay, this line and that line, that distance is called the effective throat, and the face will be the top surface of the welding, and the toes are similar to the previous one, the toe of the welding. And the most important thing in the case of fillet weld is the leg size, because how much welding you need to conduct do will be defined as the leg size. For example, in an industry, if you are asked to conduct a welding, a fillet welding, then you will be given a parameter like the leg size. The welding leg size, let's say 5 millimeter welding, 5 millimeter welding leg size has to be welded. Okay, so that will define how much welding you need to conduct. Okay, and also when you design a structure, like how much load this structure can take, then that can also be calculated using the leg size of the welding. Okay, so this is an important parameter for welding. Okay, so for various zones that I was talking about in the part welding joint terminology, the fusion zone is basically the zone where all the metals get completely liquefied due to the high temperature. Okay, in this zone, the material will be completely liquefied, and this is actually the interface. Okay, this is actually the interface, and after the interface, this region is called the heat affected zone. This region is called the heat affected zone, and this is the base metal. And what happens in these regions is that it is explained in here. Okay, when the metal is completely liquid and then the welding is complete and it has been solidified, then in the fusion zone, if we look at the microstructure, the grain structure will be like columnar grains. That means very long grains will be seen in this in the liquid zone. And in the interface, after the interface between the fusion zone and the heat affected zone, the grains size will be changed. The coarse grains in the heat affected zone near the weld interface, and the fine grains in the heat affected zone away from weld interface. That means close to the weld interface, grain structures are larger. Okay, most largest grain will be found in the fusion zone, and then after that the coarse grain will be found in the heat affected zone, and the later one the grain size will decrease. That means finer grains will be seen in the heat affected zone, and this will be the original cold work grains. That means uh, the the base metal, in the base metal, the original structure of the material will remain in these locations. Okay, and that's how the welding, because of the welding, the material structure changes. And one thing I need to mention here is that the welded joint is much stronger compared to the base metal. It's because the heat treatment is done in this location, and because of this columnar interlocking grains. Okay, that is why the welded zone is much stronger. If there is any failure in the welding, then that mostly occurs in the interface between the heat affected zone and the base metal. Okay, this is the prominent region for failure of the welded structure. Okay, any question?
Sir,
Yes.
sir, last point. Can you explain again, sir? Last point. Didn't understand that.
That means this region.
Yes, sir.
This region is the base metal. Original grains will be there. Okay. The original grains are basically like elongated grains. Depends on the how we prepared this material. The base metals. The base metals original grains will be the same as it is, but the region in the heat affected zone, those grain will be affected, and they will create like different grains. Okay. And that's why the property of this zone will be different from the base metal property. Okay.
Sir,
Yes, sir.
sir,
Okay.
in the face of the weld, we can see that there is some extra material from the base, but is it necessary in the last final product?
Actually, it is not necessary. Okay, most of the cases, as I say, most of the cases that reinforcement in this location is actually grinded off. Okay, if you need a plain surface, and if you don't need the plain surface, you can just leave it like that. Okay, and it is very difficult for welding to maintain a clean and flat face in this region. Okay, because because you cannot see this location properly. That is why you always put some extra material instead of putting less material. Okay.
Okay, sir.
Now the weldability. What is the weldability? Weldability is the ability of a metal to be welded. Okay. And okay, there many materials can be welded together, but they may not provide the satisfactory service. Okay, and that is why in that case that metal has to be treated as treated to have low weldability. Okay, in here I have shown some in the decreasing order of weldability. That means iron has very high weldability. If you weld the iron work pieces together, welding is very easy, and also in the intended service, it provides the service very satisfactorily. But if you go downward, if you go to the stainless steel, the welding is very difficult, and at the same time, it does not provide the satisfactory service. Okay, and based on these two criteria, the welding, how difficult it is to weld, and also the satisfactory performance in the intended service. The material can be categorized as in terms of weldability, like the iron has the very high weldability and the stainless steel has very low weldability. Now the classification. Classification of welding is basically starts with the plastic welding. There are three types of welding: plastic, fusion, and solid state welding. In the first one, that is plastic welding. In this case, metals are heated to the plastic state. Do you understand the plastic state? Anyone?
No, sir.
No. Okay. The plastic. If you want to understand the plastic state, then you have to go to the people who make those knives and other things. Okay, kamar or blacksmith is the English term for kamar. Anyway, the plastic state basically is the plasticity. When you heat the metal at very high temperature, then metal becomes red. Okay, and then if we strike on the metal surface, and it deforms and remains in that location, in that region. For example, if I want to show you the plasticity in here, let's say you applied a force from this side, and this side is fixed. Okay, you applied a force from this side, the material gets deformed. Let's say this is the deformed location. Okay, due to application of the force, material is deformed. Once you remove that force, if the material comes back to the initial position, okay, this surface comes back to this initial position, then that is called elasticity. That is the elastic state. Okay, and when the material is heated at high temperature, then what happens is that if you apply the force, material gets into this location, and if you remove that load, material remains in that location. That is called the plastic state of the material. Did you understand?
Yes, sir.
Okay. So this is the plastic welding. Plastic welding is the material has to be taken into to the plastic state. When the if you apply a force, then it deforms, and deformation is permanent. Okay, and it can be forced together to two metal can be forced together to join, and as well as without the addition of filler metals. We'll look at some plastic welding methods in our later slides. And the plastic weldings are like force welding, resistance welding, thermal welding. We'll discuss about this in our later slides. The basic thing about the plastic welding is that you have to take the material into the plastic state. You don't have to melt the material. Just take it to the plastic state and then apply certain pressure to obtain the welding. And the second one is the solid phase welding. In the case of solid phase welding, it is to bring to actually impart a metallic bond between the surfaces to be joined. So if you have two materials to be joined, you take them into very close contact, that is called the intimate contact. And then if you can reach, due to the intimate contact, if you can reach the relaxation distance of the atom, interatomic force that acts, if you can bring these two surfaces together in such a way that the relaxation distance is crossed, then the metallic bonding will be formed in this region. Okay, and because of that metallic bonding, material will be joined together. Okay, and that is how the solid state welding is occurred. And in the case of solid state welding, to bring the material surfaces into intimate contact or into the less than relaxation distance, then you have to use the solid. You have to conduct that operation at high hot state. That means the temperature has to be increased. Higher the temperature, the relaxation distance between the atoms will be decreased. Okay, and then you can easily join the material together. Did you understand the relaxation distance? Do you know what is relaxation distance?
No, sir.
Okay. To understand the relaxation distance, you first need to understand how metallic bond actually works. The metallic bond is basically the sharing of electrons. If this is iron, let's say this is iron, and the atoms are in here, and the atoms of iron has the electron in the outer shell, and those electrons are shared by all the atoms together in the metal pitch, and that's how the metallic bond works. Okay, when you bring these two iron pitches together at high temperature, the atoms actually vibrate at very high velocity. That means the atoms will have the very high kinetic energy, and because of that kinetic energy, the atoms will be in such a close distance that the atom from this piece and the atom from that piece both can share their electrons, and those electrons can flow from this metal surface to that metal surface very easily. Okay, and the distance at which this phenomena occurs is called the relaxation distance. Okay, and how this solid phase welding is done, it is to reach the surfaces. You have to reach the surface distance between the surfaces has to be less than the relaxation distance, so that electrons from one metal piece can easily flow to the another metal pitch. That means the atoms of one metal pitch can share their electron with other metal pitch, and that's how the bonding actually creates, and it has to have at very high temperature. Okay, did you understand now?
Yes, sir.
Okay. Third one is the fusion welding. In the case of fusion welding, the material actually completely, you need to melt the material completely, and then you get, after solidification, you get the bonding. Okay, you get joining. And heat, in the case of fusion welding, heat can be generated in various ways, like combustion of fuel, electric arc, electric resistance heating, plasma arc, electron beam, laser beam. There are many other heating methods that can be used to join the metals together. You have two pieces of metal together, you heat it up to melt the interface, and then you get the, after solidification, you get the joint. That is called the fusion welding. Plastic welding can be like resistance force or thermal welding with pressure, but we will concentrate on the resistance welding. The resistance welding may be subdivided into 1, 2, 3, 4, 5, 6 different types of weldings. One is the spot, percussion, seam, butt, projection, seam, butt, flash, and percussion welding. We'll discuss all of these processes. The first, we start with the spot welding. Before going to the spot welding, what is the resistance welding? Resistance welding is basically when you have one metal piece in here, and there is another metal piece at the bottom, and you have an electrode at the top and another electrode at the bottom. Okay, and this may be the positive terminal, and this may be the negative terminal of the power supply. When you apply the power, that means apply the current to flow. That means in the case of welding, you have to remember that the voltage will be very less than 60 volt, less than 60 volt, but the current will be sometimes can also be 1500 ampere. Okay, and sometimes it can be more than that too. Because of the high current and low voltage, and there is a huge amount of resistance between the plates because of the air gap between the plates. Okay, these two plates are close together, but there will be air gap. Okay, because of that air gap, there will be very high resistance, and we know that the heat generated due to the current flow is equals to I square R T. That means time. Okay, R is the resistance, I is the current, and T is the time. So heat equation, according to the heat equation, for a certain time, if you flow the electricity through this through this setup, then due to the high resistance in this location and high current density, there will be huge significant amount of heat will be generated, and because of that heat, the material in this location will reach to the plastic state, and at the same time these two electrode actually provides certain pressure on these two specimens, and due to the pressure and at the same time the high temperature, material reaches the plastic state, and once it is removed, then the material gets joined. Okay, and that is how the resistance welding actually works. Do you have any question? Okay. So the first type of the resistance welding is spot welding. It is the purpose of this spot welding is basically to join workpieces, long workpieces or sheet metals together. Okay. For example, if you have looked at the transformers, they have some fins like this, right? Fins like this. Those fins are joined around the surfaces. Okay. Or also, if you look at the automobile bodies, automobile bodies has to be joined. Different sheet metals has to be joined together at various spots. Okay, and to join them together, you can use the spot welding. It is very convenient and takes very small amount of time, and gives you a very convenient joint. Okay. And how do you conduct this spot welding? In the case of spot welding, you have to have two things. One is heat generation, and another one is pressure. Okay. How do sorry, not R, pressure. How do you do this? To generate heat, you need to supply the electricity to the electrodes. So there will be two electrodes at the top and another electrode at the bottom. The bottom electrode is most of the cases fixed, and the top electrode can be moved up and down to apply pressure. Okay, then you can apply heat and pressure together to get the spot in the desired location. So you will have the two workpieces on top of each other, and then you have this the top electrode. And once you the sequence of the welding is basically you first place the workpieces together, and then you using the movable electrode, you apply the pressure on the weld surface, and then you turn on the electricity. Okay, you turn on the electricity. Once the electricity is on, the material will get melted and joined together, and then you release keep under pressure for a certain time, and then you release it, okay, to get the spot welding. And the electrode can be of different type. If you want very small location to be spot welded, then you can use like pointed electrode. You need a larger location than dome. Sometimes you can also use flat or truncated type electrodes. And also another thing is that you also need to have a cooling method to cool the electrode, because the temperature, most of the temperature is generated at this location, at the interface between the workpieces, and because of the high temperature, high contact, the contact pressure between the workpiece and the electrode, there will be slight temperature generation, and because of that temperature, the electrode may not service properly, or electrode may be distorted. Okay, and that is why you also need to have water circulation or cooling method in the top electrode basically. And in the bottom electrode, you don't need that. Okay, and that is how you conduct the spot welding. So I would like to review the welding method again. First, you place the workpieces together, and they on top of the fixed electrode, and then with the movable electrode, you apply the pressure, and then you apply the current. You ensure the current supply for some time, and once the welding is complete, melting is complete, then you turn off the electricity, and then you keep it for some time under pressure. Otherwise, the material will be distorted, because these are the sheet metals of very small thickness. That is why if you do not keep it under pressure, then the material get distorted. Okay, and you will not get proper joint. That means you need to have provide some time for proper solidification, proper decrease of temperature at this location, and then you remove the electrode, and then you go to the another location where you need to produce the spot. Okay, any question? All right. So the advantages of this welding is very efficient energy use. That means the time required for completion of welding can be very easily controlled, and how much spot you want is actually depends on the electrode size and as well as the time you are applying the current. Okay, so efficient energy use can be done in the case of spot welding. And limited workpiece deformation is one of the advantages. That means you have a very small location of the workpiece that is affected. Okay, and workpiece is not melted. Okay, so that is why heat is concentrated only the spot to be welded. Only the location that is being welded will be affected because of the heat, and other material will remain same. Very high production rate because this welding takes like 10 milliseconds. Okay, less than, sometimes can be less than 10 milliseconds to conduct an welding. And automation is possible. Most of the cases, robots are used to conduct the spot welding in the automobile bodies. Filler metal in this case not required, and therefore there will be no fumes, gases, or anything else, and then you get a very clean welding. And there are some disadvantages too. First of all, the weld strength is significantly lower when compared to other processes, because it, as we said in here, the limited workpiece deformation. Okay, and also the heat affected zone is very small, so the strength will not be very high. So this actually makes it suitable for specific applications where you don't require too much strength. And for the metals that have high thermal conductivity or electrical conductivity, will not give you proper spot welding. Okay, because heat will not be able to concentrate. Because if the electron is not resisted, then the heat will not generate, and that's why it is difficult to weld silver or copper with the help of spot welding. Okay, any question? All right, the application is basically in the automotive industries or joining large sheet metals. Okay, most of the cases sheet metals are joined using the spot welding. This is one of the robots that are used to join the automobile parts at various location and various region. Okay, and this is movable electrode, and this is the fixed electrode. Okay, sorry, this is the fixed and this is movable electrode, and in any region you move to a region, and then between two workpieces, and then you just use these electrodes to conduct the welding. Okay. The next one is the projection welding. It is very similar to the spot welding. The only difference is that all other processes are similar. The only difference is that in this case there are some works to be conducted in the workpieces. Okay. That is, workpiece has to have some kind of projection like this. Okay, the place where you, let's say you have a long sheet like this, and you want to join it to another sheet like this. Okay. Then where do you want to make the joint? Let's say I want to make the joints in this location, so I make a dent in this location. I make another dent here. That means I want to join in this location. So you make all the dents on the work pieces, and then you apply an electrode, very large electrode in here. Okay, and then you press it and apply the electricity. When you pass the electricity, then the heat will be concentrated on these locations and on these locations. And once the pressure is applied, and pressure and current is applied at the same time, then a spot will be created in those locations. Okay, and this method is suitable for when you need multiple joints at the same time. If you want to produce multiple joints at the same time, for example, you have a plate like this, and you want to have joints like 4 joints here, here, and here. Okay, you can get the 4 spot weld at the same time instead of using the spot welding, where you can achieve this like you have to do the welding 4 times. First here, second here, third here, fourth here. Okay, instead of doing 4 times, you can do it at the same time if you can produce the projections in those locations where you want to do the welding. Any question? The advantages is more than one spot weld can be made with a single operation. Welding current and pressure required is less. Definitely, because spot welding, you would have to turn on the electricity 3 times or 4 times. In this case, it will be less. And the projection weld can be made on metals that are too thick to be joined by spot welding. Okay, spot welding has another disadvantage is that the work pieces that you want to join has to be thin. Very thick structures cannot be joined. But in the case of projection, if you use the projection, then thick specimens can also be joined using the projection welding. Scale rust, oil, or that means the impurities on the surface that may be present on the specimens does not affect this projection welding much compared to the spot welding. In the case of spot welding, is a region is covered, but in this case, in the case of projection welding, there is a very tiny region is in contact with the workpiece, so it will have less effect of surface impurities compared to the spot welding. Suitable for automation, and filler metals not used, so clean welding joint can be obtained. Disadvantages: the projections cannot be made on thin workpieces. In the case of projection welding, you cannot use actually thin workpieces, because if you use a thin workpiece with a projection, let's say you have a thin workpiece with a projection and you do the welding, actually this gets melted very quickly. These small regions gets melted very quickly, and that actually creates, instead of welding, that creates a void in this region, that means empty space in this region, and that will be very defective welding. That is why the thin workpieces are not suitable for projection welding. And also say at the same time, the high electrode pressure cannot be withstood by the electrodes, and equipments are costlier because you need to have a large setup. That means that if you want to conduct a lot of spots at the same time, then you need to have more expensive material like copper that is used as electrode. Okay, so the equipment cost will be greater compared to the regular spot welding. Okay, any question? Right, the application will be like refrigerator racks. If you consider the if I want to show you that this one, like this, you have the refrigerator racks like these horizontal strands, and this is the vertical strands. Okay, and if you want to weld in every joint, okay, if you want to produce weld in every joint, then using a spot welding, you have to do it like 1, 2, 3, 4, 1, 2, 3, 4, 16 times. But if you have a projection electrode like this, then you can obtain all 16 joints in a single operation. Okay, that is the benefit of projection welding. Okay, in this case, refrigerator racks, if it is cylindrical, then you don't need to have like to produce this sort of dents or this sort of projections. There is already projection, because one cylindrical specimen will be in contact with another cylindrical specimen. Okay, and then in that case there will be very small contact region, and that contact region will be welded, will act as a projection. Okay. Okay, the last one is third one is the shim welding. In the case of shim welding, you do the spot welding continuously on top of each other. You can achieve this using spot welding. Like you produce a spot in here, you produce another spot in here. Those spots are overlapped with each other. Okay, that is how we produce a sheen. That means a continuous welding job. It's called the sheen, and that will be very difficult. Okay, using the spot welder, like you have to weld many times, one here, and another one here, like this. Instead of by applying pressure with those spot welding electrodes, instead of doing that, if we use the electrode as a wheel, and it will be continuously in contact with the two workpieces. When the wheel is in contact with the workpieces and the workpiece moves to the left side. If workpiece moves to the left side, then after certain time, let's say uh, uh, when the workpiece is in this region, you turn on the electricity for for certain seconds. Okay, and then when the welding is done, and then you turn off the electricity. Okay, and then workpiece moves to the next location, and then again you turn on the electricity. That means you just have to turn on the electricity and turn it off to get the many spots and overlapping spots. You can produce the spot welding using this shim welding method, and also at the same time you can produce the continuous shim. That means pressure dried vessels can also be created. Okay, that means if you it will depend on like when you turn on the workpiece will have a constant velocity in this yeah, on the left side, and you just have to turn on the electricity to get the welds. If you want the overlapping welds, then you can just produce a weld very close together, very within a small time frame. And if you want a spot in here and another spot in here, then you can also do that. You just have to wait until this location gets under the electrode. Okay, and also you can just keep the current on for all the time to get a continuous electrode welding. Okay, that means you have the workpieces here, and you will get a continuous welding of similar thickness. Instead of various spots, overlapping spots, you can get continuous welding too, using the shim welding method. Okay, any question? No. And if you look at the advantages of shim welding, it can produce gas tight or liquid tight joints. Overlap can be less than the spot or projection welds. And a single shim weld or several parallel shims can be produced simultaneously. That means you have like the workpiece like this. You have you want to have welding in here and in here. Then you can use two rollers. That means one roller positioned in here, another roller positioned in here. Workpiece moves on the left side, and you get the welding at the same time. That means several parallel shims can be produced simultaneously. And a low cost of welding cost will be significantly reduced, because you can use you can do the efficient energy use, and the filler metal are not required in here too, and you'll get a very clean welding. Okay, any question? There are also disadvantages. Requires complex control system, and actually because of the advanced technology, this shim welding is completely automated nowadays, and then disadvantages are get removed. The only disadvantage that can be here is the initial cost of the machine. The initial cost will be very high, and also it is very difficult to weld the metals of thickness greater than 3 millimeter. It's very difficult, and welding can be done only along a straight or uniformly curved line. That means you cannot do welding like this in a zigzag path. Okay, then you have to do the welding in this location, then rotate the workpiece, and then do it again like this. In most of the cases, the welding can be either done using a very good straight line or sharp very high diameter corners. Okay, curved lines can also be welded. Applications like to manufacture the pressure vessels or aircraft wings or aircraft bodies, or that means the fuselage, or any sort of large structures like mufflers, refrigerator cabinets, gasoline tanks. This can be manufactured using machine welding. Okay, next one is the butt welding. Butt welding is it's a very simple type of welding. You apply the force and then you introduce the electricity. Okay, this is the positive pole and this is negative pole. Okay, and then when you put a metal piece together this is the welded parts. Okay, using the movable clamp, you apply the force and then you turn on the electricity. Then, because of the air gap between the work pieces, there will be heat generated and material will be melted, and then due to the application of force, the material will get joined together in this location, and then final joint will look like this because of the pressure and material. Since the material has reached its plastic state, and that is why the material sometimes get like this kind of bumps are produced, which can be machined later. Okay, very simple type of welding. And there is another one similar to this one, that is the flash welding. The only difference between the butt welding and the flash welding is that in the case of flash welding, you turn on the electricity first and then you apply the force. Because of the electricity application of electricity, when it comes very close to the workpiece, then the electric arc will generate, and that will create more heat compared to the butt welding. Okay, and because of that more heat, material gets flashed out, and at the same time force is applied, and material gets bonded together. The material does not melt; they just reach the plastic state, and due to the application of force, the material gets joined together. Last one is very conventional type of percussion welding, mostly used in electronic or electrical industries, where you want to join two different type of material together. Like if you have a copper wire to be joined with aluminum surface or a different type of wire, then you can do it with the help of percussion welding. That means you connect them together with the help of current. You apply the current and then you apply the impact force to join them together. It is basically used to join the dissimilar materials together with the help of heat generation. Heat generation is due to the electricity, and the joining is due to occur. That means interlocking joint basically occurs because of the impact hammering. Okay. Okay. Any question? All right, so this is the end of today's class. In the next class, we are going to study the fusion welding.